Hello, this is Ryan at Nextmv. I'm going to give you a quick tour of our integration with NVIDIA's cuOpt optimization platform. What I have in front of me right now is a simple app that runs both locally and in Nextmv using cuOpt to do vehicle routing. So we have here as an input that shows a bunch of jobs that have to be accomplished. There's locations, IDs, and delivery amounts, and then a few vehicles with locations and capacities to do those. We have a main.py, which is our actual app. It's fairly simple. It uses the cuOpt routing library and a few other things. It uses an open source Haversign library for approximating distance, and some code that we have here for creating GeoJSON visual output. This is just a function that constructs a distance matrix, nothing special there. And here's where cuOpt comes into play. So we're using the Nextmv library to load command line flags and arguments, data, etc., and then we construct our model. So this is a cuOpt model here. You can see it's creating a data model using cuOpt data frames for the distance matrix, and adding things like capacity constraints to the vehicles. So anything that you can do inside of cuOpt, you would put in here any custom code that you would run to change your inputs, change the model in any way. We then call solve, convert that into a dictionary, and write Nextmv formatted output. Since this is a CUDA application, it requires an attached GPU, and I'm running this inside of a dev container. So if you were to get this from our community apps repository, you could also run inside of a dev container to accomplish this locally. You can see we're using a specific runtime image which has CUDA and cuOpt installed into it, and we're using the NVIDIA runtime. So let's just run it locally inside of that dev container. So you can see down here in VS Code, I'm already inside of the container. And here I'm just going to run it with a time limit of 1, and I'm going to yank out the run statistics. I'm not going to look at the solution here. I just want to see that it actually runs. So if I do that, I can see that it creates the input matrix and runs successfully, and so on and so forth. In order to run this remotely, we have to create a manifest for the application. So this is the Nextmv manifest. It tells us this is a Python application, what runtime image to use. It also tells us, tells it to package up requirements, what CPU architecture and version of Python the libraries should be for, and what pieces of code have both the cuOpt model and the visual assets for output. Running it remotely requires that I push it into Nextmv infrastructure. So you can see here I'm going to run a Nextmv app push into an app container that I've already created. And so this is actually pushing the application into Nextmv fairly quick. It is now an endpoint that I can make requests to, and I can run experiments and do all of the Nextmv goodness around deployment and experimentation and application management. If I now switch over to my browser, I can see that this is the application that I've pushed it into. I've already been running it a few times, as you can see here. And I can do, again, experiments, so on and so forth, as long as I have the correct execution class set for this thing, with an attached GPU. Here is an example run of the input that I just solved. So you can see this is the visual asset. It also gives me summary statistics, the run output metadata, and so on and so forth. And since this is cuOpt, we can solve fairly large optimization problems with an attached GPU. So this is a version of the same problem, but with 1,000 stops and 100 vehicles. And I think I gave it 10 seconds to solve this in. All right, that's all I have for today. Thank you for your time and attention.